doctor Stefan Frei. Él es de la Universidad de Constance de Alemania, investigador en EDPs y análisis numérico, y ha sido profesor visitante o es profesor visitante en la Universidad Agraria La Molina, y también nos ha visitado varias veces al Perú en otros eventos, a otras universidades del país. Y bueno, pues él siempre colabora con nuestro país, ¿no? Perú. Y ahora vamos a aprender, ¿no?, sobre la programación con Python, ¿no? Y también nos acompaña la doctora Vanessa Knittel. Bueno, los dejo a ellos ahora con el mini curso. Adelante, Stefan Frei, Vanessa Knittel. Bienvenidos desde Alemania a Perú.
Ok, muchas gracias por la introducción. Bueno, creo que voy a cambiar a inglés, como el curso va a ser en inglés. So the course will be given by Vanessa Knittel. So let me maybe also introduce her very briefly. So Vanessa got a master's degree in Konstanz some years ago, a master's in mathematics. I think both a master's in mathematics and in physics. And then she also got her PhD in physics. And I think during all the time, she also did a lot of programming and also took a lot of courses in computer science in Konstanz. And I think that's now more or less her main business. And so she will give now a course, 4 hours today and 4 hours in 1 week, I think. Again, same time, I think, on Saturday. Yeah, so what else should I say? I mean, if you're interested in following this course afterwards, there's also the possibility to extend it. So we have, or we are preparing a project, programming in Python with applications to mathematical epidemiology. So you will get further information next week on Saturday. So if you're interested, you can, this is kind of a follow on after this course. We prepared a project for you that you can follow under some guidance. And yeah, as I said, details will be given next week. We are members of a German-Peruvian project which is going on. Actually started in 2019, which is called Peruvian Competence Center of Scientific Computing, where a lot of German universities and some Peruvian universities are involved. We have unfortunately not been able to do everything that we had planned for these years due to this pandemic, but so we are very happy to contribute to this event. There will also be 2 plenary speakers from Germany next week. And with this, I think I will hand over to Vanessa, who will give the course today and also next week. I hope that she has all the rights to share the screen and so on.
I think so. At least I can see a share screen button. Let's hope it works. Okay, thank you very much for the nice introduction. And bienvenidos a todos. As Stefan already mentioned, the class will be in English. You would hate it if you hear my Spanish, so I think it's better in English. And well, yes, I appreciate it a lot that so many are there. I hope I can make it a little interactive. I know it's hard with this online classes, and a 4-hour workshop will be really boring if just one person is talking all the time. So of course we will have breaks and there will be sessions where you do some tasks on your own. Otherwise there will be no interaction at all. So we will have first an introduction to Python, and we start with simple tasks. I hope that you have installed Python on your machine, because otherwise, as I said, you can just watch me do stuff, and this is not the real purpose of the class. So it's better if you just have your console open and Python open and then try around for yourself. Okay, let's check if the screen share works. You should be able to see my screen now, I hope.
Yes, yes.
Okay, and I hope all the screen. Can you see my console now? Yes, right. Good, okay. So first some introductory slides, and then we switch to the Jupyter Notebook where we can look at examples, and it gets more interactive then. So Python is a high-level general purpose programming language. I'm pretty sure you've heard of it and maybe used it before. By the way, then you skip basically the first part because this is really introductory, and we get to more advanced things probably than next week. Yeah, but so that anyone can join who's interested, we will start with the very basics. Also, if you have programmed before, maybe this is too easy for you, then you can just find out for yourself if there are maybe things that are new to you in Python. I will point these out. So, but if you have programmed before in any other language, probably the first part is too easy for you. So, as I said, it's general purpose. You can do a lot of things from just plotting some functions that you need for your papers up to machine learning and all the modern stuff. Also, of course, you can do file I/O and just organize your computer with it. So there are many options also for scientific use. And I think that's the most important part for you as mathematicians. Python is an interpreted language, so you do not need to compile it. This makes it easy. I mean, you don't have to compile, but during runtime, it makes it a bit slow, which is the most common criticism. But for us, that's fine for now. What's also very good is it supports basically all common paradigms. So you can use procedural programming, you can do object-oriented programming and also functional programming. We will have a look at all three types kind of quick with the object-oriented. I think the procedural and functional is more interesting for you. It is very powerful due to its comprehensive standard library. So it has a lot of functions that are already implemented, and you can use them for free. All of it is for free. You can add many other libraries and modules. For example, as I said, for the machine learning, you have TensorFlow or Keras. So many other libraries, which functionality you can just use for free. So you don't have to invent the wheel on your own all the time. And it's very easy to start with it because you just need a text editor, basically. Actually, it's okay to just have a console. With a text editor, you can write your first program and store it in just a plain text file. So that's it. It needs a specific ending, which is the .py, and a file with that ending can be called with a Python and run, for example, from a console. So to install it, you can go just to the Python website. I hope you have done that already. If not, you can do this now. It's kind of quickly done for all common operating systems. And then you can directly start away from the console. As I said, you can just use any text editor to write your first program. So, now some characteristics, because maybe you come from another programming language, and then some things might be new to you. For example, if you come from C or C++, You're probably used to declare all your variables in advance. You don't have to do this here. You can define them as you need. You have to be careful though. I mean, there are also, of course, many advantages from declaring everything in advance. Also, from typing it when declaring, this is also different in Python. So everything is dynamically typed. Not everything, there are a few exceptions which are statically typed, but in general, we have dynamically typing. That means you don't have to set the type of your variable when you come up with it, when you define it. For example, you can just write x equals to 1, and it will be saved as an int. So you don't have to define integer x in advance and then assign a value. So this is read from the value. But you have to be careful. We will come to this later. It's a common source of errors too. What is also very easy, and this makes it quicker to learn than C or C++, is that you have completely automatic memory management. You don't have to take care of garbage collection or OS specific things. So all this is done for you in the background. And then the most common, well, yeah, maybe unknown thing to people coming from or migrating from other programming languages is that the blocks need to be indented. So if you have, for example, a for loop, you have to do the indentation. This is mandatory, as in this example here. This makes your code, of course, a little bit more tidy because you have to use it. But if you nest a lot of functions, I mean, yeah, there will be a lot of indentation. So keep this in mind. Probably this is the most common thing to learn in a new way if you are used to, I don't know, do MATLAB, for example, or C. Here we have an example for that. So on the left-hand side, you see Python code for if and else statements. The C equivalent is on the right-hand side. There's also indentation, but you don't need it. You can use it in C and then makes it look nicer if you have the indentation. But you don't have to use it. You have the brackets. The brackets are mandatory. So these we do not have here. You see that you have to keep track of the indentation to see what belongs to the if statement. Don't worry if you don't know yet what an if statement is. We will go over common control flow in a minute. So we will repeat all this or introduce all this. Just as an example, not brackets are relevant, but the indentation is. So keep that in mind. It's a very common error. However, usually the error will be given in the console and telling you that something wrong with the indentation. Just these errors where it still works, but things are not done in the correct place, they are mean, of course. So as I said, if you have nesting to a higher degree, you need to indent further and need to keep track of where you are. So there are many ways that you can run Python. I think the easiest thing is to just run it from the console, but of course it's not very useful to do this when you want to write a bigger program. You should hopefully see my console now. Somebody tell me if you cannot see what I'm typing now. So to run it from the, yeah. Can you see the console?
Yes. Yes.
Okay, if you have Python installed, you can just type Python. And now I'm in the Python prompt. You can see this by the 3 little arrows here. So when typing now, it will be interpreted as a Python command and not a normal shell command as before. So my shell is used for Python commands now. So what I can do is write my first program. For example, I can print hello world to the console. The print statement just returns the argument as a string to the console. So if I enter this, the prompt will return me the hello world statement. That's it. I use this in the console very often just to calculate quickly something. If I'm too lazy to calculate, I don't know, 4 + 2 in my head, I can do this here. So for quick things, quick calculations or some tests, it's just convenient to do it in the console. If you want to write a bigger program, of course, it's useful to write this in a separate file. So we can leave now Python. We use quit as a command. Don't forget the brackets. Now I'm back in my normal shell. And now I can open any text editor. For example, I can use Nano now and already give a name to the file I'm using. Like, for example, I don't know, my program or so. .py, so that is interpreted as a Python file. Now I'm in this file and I can again write my commands. For example, I want to print hello world again. And then I save it. So this is now written in my Python file. And now I have to store it. I can check if it's still there. If I look at the content, that's now the command I saved in the Python file, and I call this file now with Python, and then the command is interpreted by Python and hello world is returned to my console. Of course, also this is not so convenient as you have to switch back and forth all the time between your editor and your console. So if you don't want that, you can, as the third option, use an IDE. Yeah, that is the 3 options we have. Either you run your commands from console, or you use some text editor. If you haven't installed anything special yet, any IDE, you can now proceed in console or in text editor. Any is fine, even Word. And from here, you can also install now an IDE like Spider, for example, or Jupyter Notebook, which I will use later. Spider, I think, is the most common one. I can show this to you here. So here you have a console on the right-hand side. Here I can type commands to the console, but directly next to it on the left-hand side here, I have an editor where I can change my programs and then run them directly. For example, here's now an empty file. I can start my program here now. Again, for example, print something. Peru. So I can test directly the command by clicking run now, and then I see the output in the console. So this is easy because you have both things in one window. Also, if you come up with some variables, you can see how they are stored, keep track of all the variables you have. So I think this is the most convenient thing for bigger projects. Also, this is freely available for installation. So for the more advanced programs, we will come back to Spider. But for now, just that you know, you can install it now. It's not mandatory to have it yet. So, by the way, I will send you the material, so you have all the links. And also the Jupyter Notebook with all the examples I can send to you. I got a list with all the participants and an email saying that I can send material to you, so I will do that. So you don't have to copy everything. Then there's one more thing that can cause a lot of problems. There are many versions of Python, and not all of them are backwards compatible. So the most standard versions are 2 and 3. If you have installed Python already, you can check which version you have. I will be using version 3. You can have both in parallel and then switch. So if you have 2 and you need it for something, you can nevertheless install Python version 3 on the same machine, and then you just switch between the machines. I can show you how to do this, for example, also in Jupyter Notebook. Most of the functionality is the same. There's a few things where you have to be careful. For the most important differences, I will point them out when we come to that point. And if you get confused and something is not working in your example, as maybe in the one I show you, just check again if you were using version 2. This could be a reason. To check the version, you can just type Python -- version in your console. And also you can switch to a specific version by just naming the one. For example, you want to switch to Python 3, you type Python 3 instead of just Python. Okay, so I hope that you have Python installed, any of the 2 versions, and can follow along with the examples that we look at. As I said, I will send the material to you, so there you will have also these links with very nice books and tutorials. Most of them are for free. For example, the official wiki is of course for free and is very comprehensive, so most of your answers probably you will find there. If you need more guidance, you can look at one of the books, and as I said, you will also get the Jupyter Notebook with all the examples from me, so you have this too. What I also want to recommend is the app Solo Learn. You can install it on your phone. It's a bit like if you learn a language, just for programming language. So there are tiny little tests, and I think it's very useful for long bus rides where you don't have anything else to do. And especially if you migrate from another language, because then it's very easy to get to know the syntax. So there are little quizzes, and so it's fun to practice with it. Okay, so the slides I will send to you, and now on the following I will switch to Jupyter Notebook. The Jupyter Notebook is like a special file in which I can show you text as well as tiny cells with code snippets, and you can run them directly within the notebook. So you can think of it as a sum editor for text as well as little code cells. And if I send it to you, you can open it just in HTML. So I have it open in my Firefox browser now, but then you cannot run the cells. If you install Jupyter Notebook, you can also run the code snippets and directly play around. Like for today, I think it's fine if you just play around with an open console. It's probably the easiest way. Okay. So today we will start with the basic concepts. This introduction is based on an introduction by J.R. Johansson, and his course is way longer. So especially if you're interested in a certain module, then maybe his course has some follow-ups. It's available on GitHub. That might be interesting for you if, for example, you want to have a closer look at a special module or a special library, like, for example, I don't know, machine learning with TensorFlow or so. Okay, so these modules, they're basically like libraries. They give you all the functionality that is already available in Python. So usually you load the modules that you need and work with them. You don't have to do everything on your own. So the standard library has a lot of included already. You can do, for example, file I/O. You can also communicate with your operating system. You can do all the typical string operations. And of course, it has also a math library for standard mathematical functions. This one we will need for sure. That's why we import it first. All the modules that are installed on your machine need to be imported every time you want to use them. So they are not just there. So if we decide to need the math module for our program, we have to import it before using the program. Or you just put this as a first line in your program. So this is one of the code cells I mentioned. This one I can run now. If I click run, we don't get an output because nothing happens that we could see, but in the background, I now imported the math module, meaning that I have all the functionality of this module now at hand. And actually the whole module is now there. Maybe I will make this a little bigger, the font size, probably more convenient. So the module is now imported, meaning I can use, for example, the cosine function. This is not in the general Python standard library. I have to import math module. Now I can use cosine. If I run the next cell, I can calculate now cosine of 2 pi. As you can see, the constant pi is also only available in the math module. This is why I have to type math.pi in advance. Now, cosine of 2 pi is calculated and I print the result to the console, which is 1. Yeah, if you use the Jupyter Notebook, the output is given right below the cell. So x is 1, or is evaluated to 1, which is correct. That's a cosine of 2 pi. But as you can see, you have to type math.function or math.constant. And this is maybe a bit annoying. So what you can do, you can import the module to the namespace where you're at. Then you can do this. You just type from math import star, which means we import all the functionality to our current namespace. Then cosine function is directly available as cos and pi is directly available as pi. So I don't have to type math dot and function name. I mean, this makes it shorter, but it might happen that you import several modules and then there are 2 functions with the same name, because not everyone checked all the other modules when programming their own, and maybe they added functions that have the same name. So this can cause trouble. It's more convenient if you're sure you don't have any double names, then just do like this and you skip the math. Otherwise, it's safer to import it with a name. But this can be any abbreviation that you like. Then you use the as statement. You can say, I import math as M, and then at least you only have to type an M. So this makes it quite short. Now, math module is important as M, is our abbreviation, and we can type m.cosine. So there's one more option. If you are sure you only need 1 or 2 functions, and at the full functionality of the module, then you can import only these. Then you are also sure that there are no double names or no other clashes. So you can, for example, only import cosine and pi. And then you have to know the name, because you have to name them, and then you get exactly what you wanted. In that case, cosine and pi. So this is the standard ways to import functionality from others or also from your own modules. You can write your own modules if you're sure you will reuse function very often. You can put all standard functions in a module and import it before going on with other code. So as seen in the last example, By the way, while I'm talking to you, of course, you can just test all this. Go to your console, type the commands, play around with it, try if sign or so is available. So feel free to do this all the time during the class. Yes, as seen in lots of example, if you want to import special functions, you need to know if they are there and what their name is. For example, cosine could also not be cos, maybe somebody named it cosine in the full name. To check what are the names and the functionality in a model, you can import it and then print the directory. Then you get information on what it's in there. So for example, if we do this for the math module, you can see apparently there's some seal, probably some rounding function. There is remainder, there's a sign, decrease, some cosine hyperbolicus. So many of them, apparently we can guess what they mean. For example, SQRT will probably be the square root. But if you're not sure, you can just check with the help function. All the standard modules, they have very good documentation, and you can just call the help to check what some function does. So in that case, I import now math module with the full name. So I have to type this. And I want to check what is the log function. If I type help of this function, I get information, and the documentation tells me, apparently I can calculate the logarithm. And also it gives you information how to use a function. So as you can see here, it is a function. It comes with these round brackets, and you can give 2 arguments to it. If an argument in a function has these not round brackets, is optional. So by typing just log of some value, it will return the natural logarithm. If you do not indicate the base, then the natural logarithm is handed back. So log actually with 1 argument is ln. We can check this here. We want log of 10. You can run the cell, apparently it's 2.3. So the base of this standard log is E. And if you require another base, then you have to specify it. So for example, to the base of 2, you just put a 2 as an optional second argument, and now you get another result. So whenever you're unsure how to use a function, just call the help. And if you don't want to do this in your console, you can of course also Google all the things. Yeah, as I said, the wiki is very comprehensive. You find all the results and documentation there as well, also with many examples. But as a quick way, you just type help to the console and you get all you need to know. You can try this on your own. You can try help, for example, on the full module. So you just type help math. This is also possible. And if you want, you can have now just 1 or 2 minutes on your own and just test what all these standard libraries do. So many important libraries are sys, math. For example, threading also can be useful to you, or OS. This helps you to communicate with the OS, for example. And if you want to know what to do, you just go now to your console and try help math, but just with any of these libraries you want to figure out what they do. You now have 1 or 2 minutes to play around a bit and test on your own. Or also import the math module and play around with this a little.
Vanessa. Hi. I don't know if you can see my face, but someone asked something on the chat a while ago.
Can I see the chat somewhere? Yeah, now I can see it.
I can read it if you
Ah,
like.
yeah, now I can see. Well, just to go back. So there are a few questions. I can keep this chat window somewhere here so I see it directly. But then you also see it. I mean, it's not so useful then. So, how to clean IDE screen? So you mean in Spider probably. So when you go to Spider, you can just, if you want to clean your console, you can type clear here, and then it's reset. And if you want to clear your program, you, for example, just open a new file, and then you can start all over again. I hope this answers this question. Then there was another one, I think. Oh, where's again my chat? Ah. Google Collaboratory can be used, I guess, as you can, for example, when you just want to share files and co-edit them, it doesn't matter if they have a Python ending, and then you have to just run them on your own machine and your own installed Python version. So you can do the collaboratory. As I said, it's plain text files, so there's nothing special about them. Just make sure that everyone who works on the same file and tries it out has the same version installed. And then difference between import and from. We can go back to this. So the from is not without the import, as you can see. You can do import, then you get the complete module, but named as it is named in advance, that is math. If you use from, you can specify what you want to import from math. The from says where you want to get it, and then after import, you just tell it what you want, and then it ends up in your current namespace. This is the main difference. So if you put a star, then you basically put a wildcard, meaning then in this case, I get everything. And in the other case, here, I just say cosine and pi, and I only got this and not the full functionality. So the from comes together with the import, but if you set the from in advance, you can specify later what you want to import and maybe not use the full module. So then why don't we get mlock? So, we should get that. You can try it. Where did I try it? So if we try log, what was the suggestion? 1000 to the base of 10. Can run this. Some rounding errors. But this is odd. I thought for this it should work. Yeah, I'm a bit confused too why this is rounded not to 3. But this might be a problem of Jupyter Notebook. So maybe because probably this has a very limited space. I could try it in the here. Also, probably because it's cut off. So, yeah. This is another thing. If you do any calculations, numerical calculations, you get rounding errors all the time. You have to keep that in mind, of course. So, depending on your machine, you get in trouble earlier or later. If you have a 32-bit machine, I mean, then there is less bytes available for storing digits. 64 bits is a bit better, but still also this is finite. So you have to do rounding at some point. Okay, then I think this was all the questions in the chat so far. And you just type again if the question was not answered to your full expectations, then I come back to it. Okay, so then we come to variables and typing. Of course, you can name your own variables. You don't have to use only pi and constants that are already stored. You can basically give them any name with some rules that you have to follow. So you can, all the letters and numbers, you can use all of them. Also, you can use some special characters. But usually you don't start with a number, you start with a letter. If you use lowercase, is typically a variable, and if it's uppercase, it's a class. This is a convention, you don't have to do this. It will work if you ignore this, but it's come to do this, to divide in lowercase and uppercase, variables and classes. Then there are a few keywords. These cannot be used as function names or as variable names because they stand for a command or an operator, for example, AND or continue, def, all these, else, if, while. I mean, they are function keywords and they are basically not an option for you. So if you type these, they mean a specific thing. So your variable needs another name. Be careful, lambda is one of those. I mean that else and if are within and return are within the list. This is no surprise, but lambda is also. And lambda is something that, of course, mathematicians tend to use as a function name or as a variable name, because, yeah, very often constants are named lambda. We will come to that later. This is not possible because it stands for a specific type of function and is blocked because of this. Actually, it stands for unnamed functions, as we will see later. Okay, if you want to declare variables, you can do this by just assigning a value. You don't have to declare in advance and you don't have to type. So by typing x equals 1.0, we directly have a float. We will see this in a second. If I run this now, my kernel knows x is equals 1, and by typing this .0, it already interprets it as a float. Also, another possible name is my variable, and also this would be a float. I can check now by typing type of x, and it's returned as a float. So this is the dynamically typing I was talking about. And if we had assigned 1 without the .0 to x, then the type is interpreted as an integer. Be careful with this. Very often this can cause problems because, for example, in numerical calculations, you use 1 as a typical starting value, and then this x would be an integer. And there are sometimes problems with NumPy arrays. We will come to that later. Once they are an int, they will stay an int. So this is not with the dynamically typed variables. They can be casted to other types, but not always. So sometimes things stay an int forever. And if you do a numerical calculation where you slowly but surely go from 1 to maybe 1.0001, then you need to convert into a float. And this is not always done automatically. So we will see later when these problems arise where to be careful. For now, you just remember the type is read from your assignment. So x equals 1 is interpreted as integer. You cannot do things with the variables that are not yet there. If you haven't defined y, for example, you will get an error. By the way, the errors usually they are quite nice and tell you what went wrong. So you have it easier to figure out where to check for your error. So in that case, if you get a name error and it actually says, oh, your problem is in that line and the name Y was not defined before. So I never defined Y, so I cannot print this variable to the console. So keep in mind, check always the exact error message and it will help you to proceed. Then there are, of course, more types and floats and integers. These are the most common ones, as you probably know them from other languages. Strings are there. You can just use this to come up with a string. True and false are keywords, as we have seen here. Actually, they're not in the list, but they are keywords. They are booleans, the two that you can have. There are complex numbers. Note that J is used and not I to indicate the imaginary part. If you have a complex number, like X here now is complex, you can access the real value and the real part and the imaginary part of it by using .real and .ima. And then you get the tuple of the two. I'll just quickly check in the chat if there is a question. Oh, no, doesn't seem to be anything. So all the typical types are also available in Python. So float, integer, unsigned integer, strings, booleans, complex numbers. Then we have a list of typical operators and comparison operators. So of course you can do plus and minus, you can add and subtract, you can divide, you can get the remainder of something, you can do modulo calculation. So all the common operators, if you are unsure which was the command in Python, you can just quickly Google it. There's a few that are a bit different. So that is to the power of is 2 stars, as if you would multiply twice. So multiply star means to the power of, not this circumflex that you usually have. So this might be a bit new to you. And also division, there we come, that this is one of the things where it matters if you have Python 2 or Python 3. So in Python 3, this is the normal float division. And if you want an integer division, you have to use it twice, the dash. So add backslash. I took a note for this because this happens very often that you get confused. So this operator is different in Python 3 from Python 2. In Python 3, it's a float, normal floating point division, and in Python 2, it's integer division. So the numbers are not even rounded, they are cut off. So be careful with this. Also with the power operator, 2 stars and not this dagger. This is actually XOR. Then as you can see in the list, there's also ways to compare 2 values. You can, with 2 equal signs, you can check if 2 values are equal. And not equal is not with the tilde, is with the exclamation mark. So not equal requires an exclamation mark before the equal operator. And of course you have the lesser than, greater than, etc. The logical operators and, or, and not are spelled out. So you actually type the word. And to negate, you need the tilde. So here in front of the equal sign, you use exclamation mark for not equal. And to negate, you can use the tilde or the not. Good. Of course, you don't know them. You don't have to know them by heart. You just look them up whenever you need them. We have a few examples here for equality. As I said, you have the two equal signs. So this evaluates to true. You can also use the is keyword. This also would evaluate to true, as in this case, the lists are equal. What a list is, we will see later. So, with the types module, you can find out more about the types. When importing it, as I said before, you can check the directory and see what's in there and then call the help for the specific function that you're interested in. And there you have, for example, the type of X is or is instance. Then you can check if something is, for example, a float. In that case, X was 1.0, so floating point number. So this equals to true. You see that Python is very often very close to standard language. You very often can just type the sentence that you have in your head. You want to know if type of X is a float, and then type just that. You can also use is instance. Also here, the name already tells you what the function does, and if unsure, you just call the help. Then with the dynamically typing, we have also implicit typing in the background that you don't really notice. This can be a source of error, so have this in mind. For example, if we have X is assigned the value of 1.5, then this is a float, but we can not implicit but explicitly cast this into an int. Running the next cell makes our 1.5 an int. And as you can guess, it's not rounded because it ends up as a 1. So if you want to check for sure, you can try another value. Again, this is not rounded, it's just cut off. So to make an int out of this floating point number, just all the rest behind the dot is just cut off. And this makes it an integer. Then, as we learned, we also have complex numbers. These you cannot just cast into a floating point number because the machine wouldn't know what to do. I mean, there's too many arguments. You could come up with something like, I don't know, just taking the real part, for example, but we will get an error because there is nothing stored in the background telling the machine what to do. This is just one dimension too much in the complex number, so you cannot convert it to float. So if something's not possible, it will tell you, you will get an according error. So, but as we have seen before, you can extract real part, you can extract imaginary part on your own. Then we come to more interesting types. So strings are also very standard, I assume. So if you use these or also the double quotes, single or double quotes, both will work fine. You will get a string, as you can see here. Type is str, so string. And there are many functions that can help you deal with strings. So you can ask for the length of it. This is done by len. So this has now 11 characters. So 11 is returned. Then there are many other functions. You can, for example, replace a substring. If you want to know more about functionality, just Google for string and library in Python. So by replacing world with test, we get a new string, the rest is kept, we have hello test now. Strings basically are very similar to lists or arrays, meaning that you can access them, and then you need these brackets. So here you need to be careful. Indexing starts at 0. If I want the first character in a string, and it's the same also for lists or arrays, if I want the first, I need to put a 0. So we start counting at 0, not at 1. So the first character in my string hello world, S was the string hello world, is an H. You can also get more characters. So you can say, I want from 0 to 5 everything. Then you won't get everything because the 5 is omitted. If you use a start and a stop index, then it will not give you the stop index. So you get, in this case, 0, 1, 2, 3, and 4. So the complete word hello. This is obvious when trying to access from 4 to 5. This just gives you the 4th character, which is basically the 5th as we start counting from 0. You can also, and this is a bit different from MATLAB, omit start or stop. So you can just put this and then you get everything up to the 5th, or from the 6 everything to the end, or just everything. So if I run these, I get everything up to 5. Here I get everything from 6 onwards, and here I get again the full string. As you can see, we just send the result to the console. The original string is not changed. This is why it's still there when I access the full. So the original copy is not changed. Just check the chat for questions. So nothing for me, just for YouTube. So then it might happen that you don't want to access every single character, but like here, but maybe you want only every second. So then you can also give a step size. You say start to end, but give me only, for example, every second, and then we get this every second character in hello world. So then for the next part, we will go over this very quickly. You could just look at it on your own. It basically tells you that it's possible to do some, making the strings nice to print them. As I said, the print statement just sends the string to the console. If you have many arguments, they will be concatenated. So string 1, 2, and 3 are just concatenated into one string, and this is returned. Formatting can be done just as in C, for example. So you can, for example, say how many digits you want before and after the dot, etc., etc. This will be necessary if, for example, you want to do a nice plot for your paper and want good formatting at the axis. But you can look at it if you need it. It's not very interesting to see it in detail now. Just keep in mind it's possible to do a lot of typical string formatting. For example, here it's possible to just say how many digits you want to have before and after the dot when printing a variable to the screen. To run this, for example, it says I want the output as a float and I only want 2 digits behind the comma, so this 3.1415 is cut off and we only get 3.14. Also rounding is possible. Using D says I want this formatted as an int and the 1.5 is round to an int, or actually cut off. So just look it up if you need string formatting, it's possible. You don't have to know the details now. Now you have a task on your own. So you can open your console or your IDE or whatever you want. And I will keep this task on the screen and you can try for yourself. The task is to compute the value of a polynomial and print the result to the screen. So you have to enter somehow this polynomial of order 2 and then try to evaluate it at x equals 0 and x equals 20. And a, b, and c are these given constants. You can define variables, you can add them directly, this is up to you. Just try to play a little with the code, come up with some solution that calculates you the value of this polynomial evaluated at 0 and at 20. I think it's okay if we have like 5 minutes or so, you can ask questions to the chat. And also if you need more time, you just tell me in the chat and then we will wait a bit longer. So now you have a few minutes on your own, and also you can try other things like try to come up with another function, another polynomial, whatever you like. There's a question in the chat. If the slicing works with arrays, it works. We will come to arrays later. In the normal Python standard library, we actually do not have arrays. We have lists, and we will do the slicing of lists later. And we will also deal with arrays, but we will use NumPy arrays. This is a special module that needs to be imported. And the objects there, they are actually called arrays. And they have slicing too. So yes, this will work with arrays as well. So I already see an answer in the chat. Actually, yes, this is the polynomial evaluated at 20. I hope you did it with Python. So of course, there are many possible solutions. I will present one to you now. There are many others. You can try around later if you want and see what other options you can come up with. So the task was to evaluate the polynomial, the constants were given, and also the two values to be inserted. And one way would be to first define the constants. You don't have to do this in advance. If you want to change the polynomial a lot, try different factors, then it's handy to have them already as variables. You don't have to do this, but you can. Then you need to define the value where you want to evaluate and then come up with the polynomial. And here, probably the most crucial part is to remember that you need to use twice the star for the power of 2. The 1 star is just multiplication and 2 is to the power of. So x squared is x star star 2. And this you can just directly calculate. And now the value is stored in y. So here I came up with the variable name for it. And if you want to print it, you can use, for example, this kind of formatting, meaning that you can use F. We didn't go into detail with this, but you can use other print versions. You can use F as an indicator that this is a formatted string. Then you have the quotes making it a string. And if you have the formatting F at the start, then you can use the curly brackets to insert variable names. So if I run this, it will print X the variable and Y the variable in these two positions. So we get as an output Y evaluated at X is X equals 0 is minus 6. And as the answer was already typed in the chat, 414 if 20 is inserted. As you can see, I have two print statements. Print statements will always, all of them will be evaluated. Just that you're not confused, one more thing, you can also print something to the console by just, I don't know, just typing the variable name and nothing else. So if I run this, also X is output to the console. If you do not use print, but this shortcut, only the last will be sent to the console. You see, if I have X and Y, only the last is output. If you want several outputs, you need to use the print statement, at least in the Jupyter notebook, so don't be confused. But in general, it's usually easier to work with the print statement. Then you never forget that you are printing something to the console. And you can think about formatting, because if you don't format, it might happen that you add few digits from different variables just in a row and you get confused what it means. Okay, so you wrote your first program. We can proceed to a bit more interesting types. This is lists. Lists is the typical Python type. You can use it for everything. You can stuff things in lists as you wish. They basically are what their name says, a list of objects, and you use this brackets, not the round ones, but the list brackets, and you can put in there whatever you want, meaning also things that have different type, and this is not common. For example, if you come from MATLAB, you cannot mix everything just like that, but you can do here. So here, for example, I have a list 1, 2, 3, 4. So for short lists, you can just enumerate everything that has to go inside. So this list would be 1, 2, 3, and 4. And if you check the type, these brackets make it a list. This is a special type. It's a compound type because the things in there, they have their own type. The objects can be of any other type. So in this case, I took a bunch of integers and stored them into a list. So this L would be a list of integers. There was a question in the chat already on slicing, if this is possible in arrays. As I said, we come to arrays later. For now, lists will be our arrays. We will use them more or less as arrays. And slicing is possible. As you see, I can just ask for a 1, 2, 3, which gives me 2 because 3 is omitted again. So either the full list or just the first and the second, which is the second and third, as we start counting again. Before, you can get also a step size of 2 and then get only every second element. Again, if you come from MATLAB, we start with 0. This is very common in other languages, not in MATLAB though. So start counting at 0. L evaluated at 0 is the first object in list. And now here you see, you can store whatever you want and also mix it. So you can do a list that contains the weirdest objects. You can have this mixture of an int, a string, a float, and a complex. It's not a problem, just put it in a list. So this is just a basket. They can also be nested. So instead of a list of ints or a list of floating point numbers, you can have lists of lists. Like this is even 5 times nested. So you have a list with 1, and the second object in the list is another list, which again contains another list. First an integer is another list, and this is nested until we have a single 5 in the last list. Of course, as you can imagine, you can make this is asymmetrical, but if you do it symmetrical, you can make kind of matrices here. So you can interpret a list of lists and say if they are all of adequate size as a matrix. But we will use matrices usually only with NumPy arrays. So it's possible with lists, but when we come to vectors and matrices, we will do this with NumPy arrays. Nonetheless, lists are very important to us. We need them for a lot of things. Because it's, for example, it's easy to iterate over them, so it's convenient to use them in loops and in other flow control statements. So for example, there's the range function. This gives you a range from a start, stop, and for a given step size. So if I want to start counting at 10 and stop at 30 and then do a step size of 2, then range is exactly what helps me here. So this would count from 10 to 30, a step size of 2. So this is perfect for iterating. You need to be careful. This is one of the specialities or difficulties with Python 3 and 2. Sometimes you have to convert first into a list. So range is not directly a list. You have to convert it to list because actually it's in Python 3, it's only an iterator. It basically means that it can iterate over things. This is a special type or a special object. And if you really want the objects in the iterator where it's iterating over, you have to convert into list. So this has to be explicitly casted into list. Very common mistake. Python 3, you get confused with maps and iterators. Very often you just need to put list around it. So this function all around range basically just casts it into a real list. So don't forget this cast if you really want to access the values. If you don't cast it explicitly, it stays an iterator. So, but casting it gives you the full range as a list. If you don't enter a step size, you get all the values with step 1. So default is a step size of 1. Just checking the chat. So you will get all these examples I can send to you. So, okay, so ranges are very useful later in flow control. By the way, you can also convert strings. As you have seen there, we did the slicing, they are basically a list of characters, a list of letters. So you can access them point by point, and you can also cast them into a list. They look different then, because now every part of it, every letter is its own object and is separated, also the space by comma in the list. Lists can be sorted. Other things can be done with lists. If you want to know what functionality is already there, just Google it. For example, sorting. So when we do this, this is alphabetically sorted because it was characters. And if you use numbers, they are sorted as well as you would normally do. You can add keywords as descend or ascend for a special type of sorting. By the way, is it possible to use also sets in Python? They are different from lists. Because as you see in this example, I have double values in my string hello world converted into a list. I have, for example, 3 times the letter L. And if I sort it, I have again 3 times the letter L. A set is indicated with curly brackets and is a real set in the mathematical sense, meaning that I cannot have double values. So every object in a set is unique. And also sets are not sorted. It's really like in a mathematical set. You cannot sort this X. It is sorted here in the output, but you cannot, so there's no function to sort it. It's just a set. And if I want to come up with a set that has 2 identical elements, then they are just combined into 1. So only unique elements in sets. So be careful with the brackets. If you use the list brackets, you can have a list of 10 times the same objects, not a problem. A set is really a mathematical set, so using curly brackets will give you something else. And it's also of different type. If you want to try what type we have now, it won't be list, but now we get this set type, yeah? And if you use the list brackets, it's list. So don't confuse it. And is, by the way, is very helpful that Python has this functionality. Not all the languages have it. If you teach set theory or some lectures that you have at the very beginning with young students, it's super helpful to show typical properties of sets. You can do this during your lecture, especially if it's an online lecture. So I think it's very helpful too. Just don't confuse them with lists. Cool. You can do a lot of things with lists. You can add or append or insert or also remove elements. An empty list is created with empty brackets like this. And then you can append letter by letter more to it. So for example, here, I can append SPAM and get a list containing spam. And then I can decide that the second letter should be a U, the third as well. And then there, don't forget, we start counting at 0. The last 2 letters are U's now. You can also insert at a specific position. If you don't want to append, appending is at the end, but you want to insert, then you have to state at which position. That's the first element. So at position 0, I want an I and so on, and then I insert letter by letter this in front of my span, which is 2 now. You can also remove all these keywords. You can Google, or also delete the complete list, or also only parts of it. Then another typical type is a tuple, sorry. Tuples are like lists, but they are immutable, meaning that you cannot change things later, and things need to be of the same type. So for example, this makes sense if you want to come up with points, because they have 2 objects or 2 elements of the same type anyway. So a point can contain an X and a Y coordinate, for example. This would be helpful to store in a tuple. So you don't need the brackets. You can omit them and just put only the comma. This is the same type. What's a tuple? If things are stored in tuple, you can get the single elements out of it again and give them also a name. So we can say X is now the first coordinate and Y the second. This is done just in the order that you added. And now the coordinates have their own name, X and Y. As I said, they are immutable. So once a tuple has a few values assigned, that's it. You cannot change it afterwards. So point is now 10, 20, and you cannot switch to 20 in the fourth coordinate. So here you need to be careful. Once assigned, they are fixed. So there's a last important type, and this is dictionaries. I think this is the last, and then there's another task for you to try around with it. So dictionaries, they have key value pairs. Also here you use the curly brackets. So just as in the sets, but with the key value pair. And this is done by quoting the key. So you use the quotes for the keyword, and then the value comes afterwards, after the double point. So a dictionary, as the name says, is a thing where you can look up the values for a certain key, like telephone numbers of people that have a name, and you look up their name and you get their telephone number, for example. The types can be whatever, so you can put also other things as floats in here. So this is its own type. It's called dict, and it contains now 3 keys, each assessing 1 value. You can also figure out what keys are in there. You can convert them into strings. You can add new entries when you already have a dictionary. You can come up with a value that's already there. So you use, again, as in the slicing, you use these brackets and you indicate that you want key 1, and for key 1 you want to change the value to A. So you assign a new value. Key 1 is now value A, as it's a string now, and key 2 has a value string B. Also, you can add a new entry, then you do the same syntax. Just name the key. If it's not there, it's not a problem, it will be added. If it's already there, you will reassign. So now I changed 2 values, and here I add a new one. So if you go back to the dictionary I had, it had key 1, 2, 3, values 1, 2, 3 as floats. And you can think for yourself what happens when I run this. Okay, so entry 1 and 2, they were changed. They have now value A and B, and I have a 4th one. And for a key 3, nothing happened. It just stays the same. Here again, you see how to access it. You just name the dictionary, do these brackets, and then call it with the key. There are other ways to come up with the how to access values and also keys. We will use this in the next task, and you just check for yourself with the help to figure out how to do it. So we do control flow before the next task, and then you have a bit a longer task where you can try on your own. So back to my, just checking the chat quickly. If you put type in list which have numbers and letters, what is its type? So a list always is of type list, no matter what is inside. So it's a list of objects. For example, if you do C or C++, you have to specify. So you have, they don't have lists, but yeah, they have arrays. You have an array of ints, for example. A list is just a list. It's not really a list of things. So we can quickly try this. Where are my lists? So for example, here, I think I had a list, doesn't matter. Just check here, we take a list where we add, for example, a string and then an int, and check its type. Yeah, this one is not known now because as is a bit difficult, by the way, if you use a Jupyter notebook and you do not run all the cells, because I sent you this, and don't worry if something doesn't work. If you don't run all the cells, then sometimes it doesn't work because not all of the variables are known. So keep that in mind. So we better check this here. So we come up with some list with objects of different type. And then we just get as an answer that this is a list. So Python doesn't care what's in it. It doesn't say it's a list of ints or it's a list of strings, because it doesn't make sense, as you can mix it. It's different with tuples. Also for tuples, it will only return it's a tuple. It won't give you a tuple of something. It will result in the same thing if you use, for example, twice ints, then it's still only a plain list. So no differentiating as in C or C++. Okay. So back to control flow. Probably you know all this when you have programmed before, so maybe you just skip this part, or maybe you check it because there's the thing with indentation and this is different from what you know from other classes or other languages. So the keywords are basically more or less the same. It's if, elif for else, if and else. So elif is sometimes a different keyword. And conditional statements work, as you probably know from other languages. You have a condition. This comes after the if keyword. And depending on if this evaluates to true, either the first part is then executed, or if statement 1 would execute to false, you jump to the next. In this case, we have an else if, so you would check statement 2. If statement 2 evaluates to true, you just do whatever should be executed here. If this also evaluates to false, you go to the else case. So you don't need the else case, you can just have the first, just an if, it's also possible. But if you have an else, then there's always something to do. So either this is true or false. If it's true, you're done. Then we execute the first. If it's false, we go to the second. If this is false, we go to the else statement. So if we run this, you can think for yourself what will happen. So we have statement 1 is set to true, statement 2 to false. Now for yourself, check what would be the result if I run the cell. We can check it. It prints statement 1 is true. This is the if case. Oh, this is a German word. Basically case. So see, this was true. So we just directly end up in the first case. And these two are printed. The indentation is important, as I mentioned before. So everything that belongs to the if case is indented. And if we jump out of the indentation, the if statement is over. In our case, it ends with the else if. Then we have indentation again, and it ends with the else. This would be the same if you only use the if case. It just stops when you go back with the indentation. You don't need the else also. So if you want to know what is executed in the if case, you check until the level of indentation switches again. Here's again the example. C would do this with brackets. This is safer. I mean, you check when does the bracket open and when does it end. But maybe it's not so tidy. Very often you end up with tens and thousands of nested brackets. I mean, that is also not tidy. So be careful to check the nesting. Here you can do two if statements. So we jump in the first execution here, and then in the second here it's nested. So we need one more indentation. And by the way, it's useful to use tabs and not spaces, because otherwise you have to count. It needs to be exactly the same amount of spaces. Common source of errors. So in this case, the two if statements are true. So this is already true, this as well. So we execute the print. Here we have bad indentation. After the if, there need to be some indentation. It's not possible to omit it completely, as you can see here. So this is one of the most common errors you get. Something is wrong with your indentation, check it. So there must be some indentation. I mean, you could argue maybe this if statement doesn't make any sense. It's my problem that nothing should happen there, but that's not possible. You have to indent, otherwise you get an error. So you cannot have this unuseful if statement like this. So here, for example, you can also think for yourself, what's the difference between the two blocks or cells here? Check careful what's different and think for yourself, what is the outcome of the two? So the text is the same. The only difference is that we have the indentation level reset here already, meaning that here we stay in the if case for all the possible commands. And here we jump out of the condition already with the last. So the statement is false. So here nothing should be printed, which happens when I run the cell, nothing is printed because this is false. So we will not execute anything that is indented afterwards. Here the indentation is taken out, so we would actually get this. Really be careful. Most important difference to other languages. So we will quickly do the for loops. And then you get a for loops while, and then you get the task. And then we have a little break. For loops, probably you know them from other languages. They are great if you want to execute a command several times. For example, you want to print X for 3 different values. You want to put 1, 2, and 3 to the console. Then you can do this with a for loop. Whenever you want to do something repeatedly, use a for loop. So for X in, you see it's again very close to normal spoken language. For X in this list, print every element. 1, 2, 3 is printed to the console. You can do this with any iterable object. So all the lists are iterable, for example, as we said before, range is iterable. Range in Python 3 is not directly a list, it's an iterator. So perfect for a for loop. Range 4 counts up to 4. Mind you, it starts with 0. So for X from 0 to 4 basically is written here, print X. So we count from 0 to 3. Also, range stops 1 earlier. So you basically get the number of elements if you don't play around with subsize, and not the highest number. So range of 4 does not include the 4, but the 0, because we start counting at 0. You can start as negative values. You can count from -3 to 3 in step size 1. You can also iterate over any list, as I said, and if this is a list of strings, it doesn't matter, then just, for example, print all the words in this list. Also, as you can see here, you don't have to define this in advance. This is also different, for example, in C. You need to tell in advance what is my iterator. Here, you just name it right when you need it. So for every word in this list of words, please print the word. And of course, you can call this whatever you want. You don't need to call it a word. You can also iterate over dictionary key value pairs. They are iterable. So to call the pairs, you have the term items. This will give you the 2. It's a tuple, as you can see, because we access it directly, both of them in the for loop. We say for key and value in this list of dictionary items. Please print key and value. So we do many steps at a time here. We have the dictionary key value pairs as tuples. We extract the key and the value separately and then print them. And we do this for the full list of key value pairs. What you also can do, if you have a normal list and not a dictionary, and you want a named index basically assigned to it, you can call enumerate. This just enumerates, meaning that it puts a number label to everything. So if you say enumerate for range, you have directly an index. So the enumerate statement will give you a list labeled with 0, 1, etc. So then you can access the first part of this tuple with the index. So now we have the zeros number, this is -3, the first, -2, etc. for all of these in range. Don't forget the 3 is not included. The last one is never included. So the last few things, and then we have another task and we have a break. So there's a really, really nice way for lists, for creating lists. This is very special for functional programming. You don't have that in all the languages. For example, Haskell is credited, but also Python lists, and mathematicians usually love it because it's very, very close to set comprehension. It's called list comprehension, and it basically works as set comprehension. Mathematicians, of course, know this type of statement. You can have a set of things and a certain condition arises, making it an object of a set, an element of a set or not. So, for example, all the positive or non-negative values in the real numbers, or all the squares of integers or something like this. And list comprehension just works in the same way. So with list comprehension, you can basically just copy what you would write in a set. For example, we have a list from 0 to 4, and we want all the squares. So we can make a new list, and directly in list brackets, we write what should happen to the elements for all the elements of another list. So here we basically have a for loop in a list, meaning we say, please give me all the squares of all the x's for x is in L0, so in this list. We print this. We have L0 is from 0 to 4, and here L1 is all squares. By just putting the list brackets around, you get a new list out of it. So this is a very short and comprehensive way to get a new list. You can, instead of a list, have another iterable object. So for example, range. This also works. Or you can do this with a string, as a string is iterable. So for example, you can, as you can see here, you can double characters. Here we have a statement. We say we want a list of things. And for these, they should also, all of them should be of the type twice x for all the x, for all the elements in the string my_spam. So m twice, y twice, spam twice. You can also add a conditional. You can say, I want all the elements in a certain range, but only if they are even, or only if they are odd, or only if they are whatever, a square number, whatever you want. You just have to put it in a condition. So here we say, please give me all elements in the range up to 20 if the element is even. So if modulo 2 is 0. So we should get now all the even numbers in range from 0 to 20, and this is just what is put out. So this is a very typical example that is very close to sets. So just quickly check the chat. Oh. Excellent, it's always good. So this convention is really fun. I have a lot of business now in the computer science department, and they don't like it so much, but the mathematicians, they love it usually because it's so close to what we usually have. Okay, so here's an example now how fast you can do things with list comprehension instead of what you usually would do. As I said before, the lists, you can interpret them, for example, as a vector or an array. And if you nest them or have a list of lists, you can think of it as a matrix. So for example, a list containing two other lists, you can think of it as a matrix with two rows. The first row has 1, 2, 3, 4 columns. The second row has 4, 5, 6, 8, also 4 columns. So this would be a matrix, 2 rows, 4 columns. At least you can think of it as a matrix. Actually, it's a list of lists. Then you want to transpose this. So instead of a 2x4 matrix, you want the transpose of a 4x2 matrix. So what you could do is you could do a lot of nested for statements. So you can say for everything in the range from 0 to the length of matrix in the first entry, which is the first row, the first list. Give me an empty list. Here we will now save everything that is coming. And then again, you have to iterate now over the other dimension and do for row in matrix, please append the current object, the current element to my new transpose row. And after this, after one row is filled, you have to append the complete row again to the new transpose matrix. I mean, it's obvious what is going on. That's the first thing you can think of, but still it's a bit complex. You have to nest the 2 for loops, and you have to write a lot. You can check if it works. So we have the first 2x4 matrix, and then transpose it, take the first column, 1 and 4, put it in the row, then the next 2, 5, put it in the next row, etc., etc. So it works, but as you can see, it's many lines. Instead, you can use list comprehension. It's way faster. So it's another matrix here, mind you. This is now one that has 2 columns and 4 rows. And I want to transpose again, and I can just directly with the row as an index for the rows and I as an index for the columns, and directly one after the other write the 2 for loops within the list comprehension. It's just 2 list comprehensions, one and the other, and this makes it so short. Basically, here I have a list comprehension that iterates over the rows, and this one is just set in the other, so nested in another list comprehension iterating over the columns. Basically, it's again the same. Again, you have 2 for loops, but it's a one-liner instead of this indented block of 6 or 7 lines. And check if this one works. It does. So the 4x2 matrix is now one with 2 rows and 4 columns. Now, the very last thing that we have in flow control is are the while loops. Probably know it from other languages. Instead of iterating over some enumerated list of things, you can say, please do something while a condition is true. For example, you can say the variable I is 0, and while I is lesser than 5, please print I to the console. But of course, you have to update the I, otherwise this will be printed over and over. So you have to count up here on your own or down, depending on your loop. And also, again, you have the indentation. What has to be executed during the while is indented here. So it's also indented a little part inside here. So the print and the counting up is in here. So what we do is we start with I is 0, evaluate if this is true, and we say yes it is, I is 0, so it's lesser than 5. We print I, we update I is now reassigned. This is probably odd for mathematicians who haven't programmed before, reassignment of things, but in programming this is typical. So we reassign I with a new value, it's updated +1. So I is now 1, still lesser than 5, we print it, we update it again, 2, 3, 4, and then we print done. what is changed when I indent now this also? You can think of it yourself. What would now be executed when I shift print done to the next indentation level? Oh, actually there's an answer, Richard. Yes, now print is done is printed every time because it is evaluated every time. Now it's inside my while body, my loop body, so it's printed whenever this statement is evaluated to true, and if I take it out again, now it's not part of my while loop, then it is just executed when the while loop is done. So we will run the while loop again, the 5 times that it is evaluated true, and only at the end we jump out of it and execute what comes at the end. Good. So this was now already a lot. So I would suggest that we have a little break. But what you can do is you can look at the next task already and try to solve it. We just give a lot of time for this task so you can have break and then just do the task. Just go over the task quickly. So there is a dictionary given. Actually, you have to copy that if you want to try it. You don't have to copy exactly this one. If you want to try on your own, just copy and paste it into your file. And the task is to get, I can't even see that, to get all the values from a dictionary and add them, the values only, not the keys, add the values to a list, but without any duplicates. So in the list, only unique values should arise. And here you can now try on your own what ways are possible to access values in a dictionary. Just use the help function for dictionaries and try to figure out how to access only the values. The second task is construct a list giving all the divisors for some integer n. So in this example here, I already put n is 20, but you can use any other number, and now is variable anyway. Construct the list, maybe you come up with a list comprehension or something else, is up to you. The list should give all the divisors to some integer n. I'd say for sure we should wait at least until 1/4 so that you have at least 10 minutes for the task and 10 minutes of break. And at 1/4 we can check again if you need more time for the task. So we will have a little break here. And you have time to start work on this if you want. And then we meet again in a few minutes. So in about 20 minutes, then it should be 1/4 not 10. Here is already 10 in the night. Then probably it's 3 p.m. at your place in Peru, I guess. So at 1/4, we can meet again and talk about the solution. And feel free to ask questions in the chat.
esperemos hasta reanudar nuevamente el mini curso. Recuerden que es hasta las 5 de la tarde, ¿ok?
So there's a question in the chat, what output arrangement is expected for task A? So only the values are needed. So get all values means we only require the numbers and not the keys. So in the list, you only store the values. So is the list like containing, for example, 54, 52, and so on, but not April, etc. So if you send solutions, you can feel free to send your solutions in the public chat so everyone can see it. I will also present a solution later, but there are many, many ways. So it's nice if you share your solution so the others can see more options. So thank you very much. Muchas gracias por las soluciones. Very good ideas. So some sent me already some solutions. So I hope you all had enough time. As I mentioned, there are many possible ways. We will now discuss a few. And feel free to also later send me other versions. Of course, you can check on your own, in your program, in your own console. And also I can check, and if something doesn't work, you can ask, and I can have a look at it, and maybe we find the error together. So now I will present one possible solution. Again, here we have this dictionary, the keys, apparently the names of a month, and the values of some numbers, so whatever this could be, the amount of rain in that month in millimeters or something like that. And the task was to extract only the values, store them in a list, but omit duplicate values. So let's have a look. So one possible solution is this. This is just again the dictionary as we saw it above. Then I came up with a list that is empty as a start. You can do this by just write list with curly brackets and no argument, or instead the list brackets with no argument. So both ways give you an empty list. This is kind of a declaration. This makes it already a list now. So as I said, you don't have to declare, but it's one possibility to start with something, kind of declare an empty list, making it only of type list, having no elements. Then I used the for loop. As it was stated in the task, you should check with the help function how to access values of key value pairs or items in the dictionary. You can do this by taking the name of the dict and then add dot values. It's a function calls. We learn this in the next step. They always come with the curly brackets. No argument. So this iterates over all the values, meaning 54, 52, etc. And items are just the values now. So as I said, only unique values. That's why we cannot directly append. We need to check if it's already in the list. So just one option, you can come up with other ways, is to say, if the current item is not in my list, the in can also directly come with the negation. If it's not in my list, again, we have a similarity to normal language. If it's not in my list, then let's append it, because if it's not there already, it's still unique. So we can check for ourselves what is going on. So this for loop iterates over the values, meaning I go in the first key value pair, extract the value, 54, I add it to my still empty list. So of course it's not yet there, append 54. Then I would go to the next item, would be key value pair, I extract the value only, it's the 52. I check, is the 52 already in my list? There's only a 54 so far. Good, so please add the 52, etc. This works again just this way for 31. When I come to the fourth pair, the value would be 54, and now this would execute to false, because now 54 is in the list. So not in my list is false. So we do not jump into this append, but instead go to the next part, so to the next iteration step. So the 54 would be omitted, the 31 same is already there, 53 is added. Let's quickly check. And this is exactly what happens. We get just the unique values. So this double 54 and 31 are skipped. This is not the only way. For example, somebody sent a solution using set of a list. You can do this. Just keep in mind that later, so I assume this was done to get rid of the double values, because if you just extract here this iterator, you can convert this iterator directly into a list and you get a list of all the values, but you have repetition, you have these again. If you put set around it, let's just type it here that you know what was meant. Set of list of year values makes a list of this iterator and then a set to get rid of repeated objects. This is fine, so you only have single ones then, but it's a set, not a list. I mean, for many purposes, it doesn't matter. You can cast it again later into a list. You should do that. If the task was to have a list, I think I wrote this here, let me check. Yeah, add the values to a list without adding duplicate values. So if you use a set to get rid of duplicates, then just convert it back into a list. Very often when you do your own program, it doesn't matter. You can choose what you want. But sometimes a task requires a certain type. For example, you want to use later on in your program a certain functionality from some module, and this module only accepts lists. And if you try to hand the set to this function, it says no way, because it was only defined for lists. Then you can try with the conversion there too, but this sometimes can cause problems. So better just do the conversion right away. But apart from that, this is a very nice idea. So as I said, this is just one example. There are many solutions. Let's look at the second task. So again, what was there to do? We need to get a list again as a return value containing all the devices to some given integer n. For example, n is 20, or choose whatever you want for n. So one possible solution is this one, using list comprehension. You name the required list devices. Do list comprehension. So what you want, you put directly in list brackets. And you say, well, I want every I, in that case, every value I in the range from 1 to n plus 1. Don't forget to end the 1, because otherwise you will not get a 20. Remember, range, it won't go to n plus 1. So the last item in this iterator range is n. And we need this because, of course, n divides n. So the n has to be included. And to have the n included, we have to go one step further to n plus 1. So for all the values in this range, 1, 2, 3, 4, 5, etc., until n plus 1, please add to my list. That's what the brackets say. Add it to my list if, now that there's the condition we have, if n modulo I is 0. This doesn't mean anything else than is divisible by this I. So I is the divisor of n, because then modulo mi n is 0. So in to make sure that n itself ends up in the list, you need to go until n plus 1. Then you have n modulo n is 0, correct, and then you add the n itself. So I've run it already. You get 1, 2, 4, 5, 10, and 20. That should be all the devices. Just to check. If I don't do the +1, then I won't get the 20. So because now in my range here, I stop at 19, not at 20. So this is absolutely necessary. Also here, I saw other solutions that were sent to me using maybe not modulus, but using the integer division and comparing it with the equal operator to the float division and see if it's the same. It's also a nice idea. So there are many possible ways. Sometimes one is better than the other, depending on what else is going on. So feel free to play around and come up with other solutions. Let's quickly check the chat. Some more solutions there. Also with the if not in, for example. And if not in, then needs to append. Nice. By the way, it's nice that you put it in the chat. But of course, if someone copies it to test it, make sure to get the indentation and the line breaks correct. Otherwise, of course, it doesn't work. So I think that is obvious. Good. Also with a bit longer condition and B, of course, you do not have to use list comprehension. Any other statement is fine. Okay, nice. Then we can proceed to functions. This is very important because you will use them a lot. If you do something with Python, something scientifically or math, you need your own functions. This is very handy because once you've defined one, you can reuse it later, etc. Also, very much later, you can do your own modules. We will also see that. And we have dealt with functions before. We used the ones that we loaded from other modules. So many people did work for us already and predefined functions that we call. But maybe we need a special one that was not yet in the module, or we need a tiny bit different. Then we can do this on our own. So if you want to define your own function, this can also be just a collection of functions, like the nested call of already existing functions. You use a special keyword, and this is called def. So def, for short for define, says now there's a new function. This is a keyword, the def. Then function name is a name that you have to come up with. So you give a name to the function, and you need these round brackets here. But you need not necessarily the signature. Signature can be there, meaning that the function takes certain arguments. There are functions, of course, that do not necessarily need arguments. We've seen one function that needs an argument. This is print, because if you don't give signature to print, then the program does not know what to print. Again, here you work with indentation to define what is part of the function body. Everything that is indented after the def keyword. So again, you have def keyword, you have the name, the signature. Here you have to put things in, your own name and the arguments that are necessary. And also here you put the body saying what is going on. So the body, we will look at it later. There are more, there's more structure to it, but for sure you need def. So here's an example. Func0 is my first function. That's the name of it. That it is a function that I define now is stated by def. Then we need a double point here at the end. And everything part of the function body is indented. So this one will just print out it works. So what should happen when I call it? We can try this. First we define it. So let's run this cell. This is just a definition, no call. Here the func0 function is just defined. And now I want to call it. When I want to call a function, I need the brackets again. We can check in the definition. It doesn't take any arguments. The signature is empty. So I don't give any arguments. So func0 needs nonetheless the curly brackets because otherwise it's not a call. It's not a problem that there are no arguments. So let's call it. If I run this call, it does what it's supposed to do. It prints out it works. So in this case, we have seen directly in the cell above what the function is. But this is not always the case. So maybe somebody else wrote the function or we wrote it in some other file that we imported and we forgot what it was. We cannot find the source code. So then we always can use help to figure out what the function does. But this help, of course, somebody has to write it. It's not just there. Calling help for everything in the mouse module does work because somebody invested time to write a help. So we can do this too. In that case, there is nothing written, so we cannot call help. But we can write our help. So here, the so-called docstring is set. Docstring is basically the text of the help. So you can just write what the function does, what arguments are necessary, what the output is, how to use it, what options you have. So in this next function, function 1 that I define, I first put the docstring. Doesn't have to come at this position, can go somewhere else. And the docstring has to come with 3 quotes. 3 quotes at the beginning and then 3 quotes at the end of it. The 3 quotes make it go into this help function. So if I call help of function 1, everything between the 3 quote and the next 3 quotes is returned. So here function 1 is supposed to take a string. You see now the signature is not empty anymore. It says print a string S. It makes sense to use the same name as up in the signature and return how many characters the string has. So this is a pretty good description. You should always make sure to write what goes in and what comes out and what's going on in between. So in goes the string, out comes how many characters it has, so you expect an integer. So apparently the thing is counting the characters. Then we check the function body. That is exactly what is described in docstring. So it says print the string again and say this has, now comes the length of it, but make sure to typecast this length again into a string. Characters. So here you have the string S has, and now you evaluate the length of the string, cast it into a string. So many characters. And this all is with the plus signs, one after the other concatenated into one long string and then printed. Let's run the cells. So you always need to run the cells because otherwise the kernel doesn't know. This is important. So if I send you the notebook and something doesn't work or you get name errors and unknown, then make sure to rerun the cells above. Now function 1 is known. So I can call help and I wrote a help. So what we get out is exactly the docstring up here. Print a string S and tell how many characters it has. So we now know how to make a call to function 1, what we need as an argument and what it does. So we can call it. It expects a string, so we have to give it a string. And then this is exactly executed. We print the name again of the string or the string itself. Test. That's 4 characters. So Now you can check what happens when I send something else then. For example, I omit now these. Now you can think for yourself, what is test now when I omit the quotes? And what should happen now when I run it? I want to make a function call. Let's check. We get a name error because when I omit the quotes, test is interpreted not as a string but as a variable name. And I did not define it, so it doesn't work. What would work is, again, this, of course, giving it a string. Or what you also could do, of course, is you could define test as some string. For example, MINICURSO or something. This is the string now. So the test variable exists, and now we can try again. MINICURSO has 11 characters. So what happens if I enter any integer? Let's see. You get a type error, and it also says exactly what went wrong. Maybe we did not check the doc string and forgot what we programmed. Now this error says, there's something wrong, unsupported operand type S for plus. So this expects a string because it calls string specific functions in here. I mean, what could have happened is that in our definition that we don't do anything with the string, or nothing that is string specific, just a print, for example, that would be fine, but getting the length is not so fine. So there's no typecasting done implicitly. So make sure to check the doc strings to get the correct types, and something like this should work without problems. And if you get a type error, just call the help and see. And if there is no help, probably you wrote the function on your own, and you have to check in the source code and better write your own help, or at least there's a tiny comment. So remember the important things for a function, what goes in and what comes out. And then of course, things have to happen in between. There's another possible option. So the functions we've seen so far were very short. There was not much of a function body. It was basically one line so far. There could be many more going on. And only in the end, you want to return the calculation after the last step, for example. In the next example, we only have one line again. So not much going on, but we send it back as a return statement. The function's name is square. It's supposed to return the square of a given number. For example, the stock string is now not very clever. It says return the square of x. You should better write what x can be. Of course, ints would do it in that case, but also floats. And then you define what is sent back, which value is returned by using the return keyword. Then only what comes here is sent back. And before that, in the function body, I can do a lot of things. For example, some more calculations for x or whatever. Return is only what comes after return statement. So let's get this run and test it. Of course, we can call square of 4. Let's see what happens. We get a square out of it, so that's good because the docstring says returns a square. So now think for yourself. What happens when I add a string and not an integer? Well, let's make it easier. First, maybe I add a float. So think for yourself. Is it possible to enter a float in this function? You can just try it, and yes, it's possible. And you can see here we have an implicit typecasting. When I enter a float, x is now a float. Then a float is squared, so it stays a float. When I send in an integer. An integer is squared and there's no need to do typecasting, so we keep an integer. So the type is actually again checked, and also the return statement is dynamically typed. But what happens if I enter a string? Like for example, test again. Is it possible to square that? No, it's not. We get a type error because this operator, you can check the help for this operator. This does not expect the string, and you get a type error. Unsupported operand type power does not support strings. I mean, we could also not think of something useful that would happen to a string. But as you have seen before, actually you can double, for example, chars. This is possible. You get just twice the char. We did this already to a string. Okay, let's get rid of that. It doesn't work, but square of 4, of course, is possible. When you calculate multiple things, then it's especially useful to have a return statement, and because then you can send all of them back at once. Again, this function body is very short. We just can do the calculation if it's short, also if it's long, completely after the return statement. Is not very tidy if it gets too long. Better than you do something in the body. Here, powers is a function that returns a few powers of x. You need to check closer, of course, if you want to know what exactly is done. So this doc string is also not very, not very comprehensive. So checking the source code, we see a square and cube and the 4th power are returned. So let's get the definition into our scope. And our call powers of 3, and you again think for yourself, what will be returned when I run the next cell? So I make a function call, and my argument is the 3. What is returned when I have a long return statement with 3 values? Let's try it. We get out a tuple. So here we have a tuple. Maybe this is not so clear because you can also put the brackets. Then it's very clear that it's tuple, but these can be omitted. The commas already make it a tuple. So everything is returned. Everything is first calculated and returned, and then we get a tuple. And if you want to access it separately, you can again give names to it. X2 is then the square, x3 the cube, and x4 the 4th power. Because then you can later access only the value that you need, for example, only the cube. So this would return then only 27. What is also possible is that you make it a little bit more tidy and, for example, calculate what you need here in the function body. You could do this. We say x2 is the square. So this is calculated here separately, and what we send back is x2 then. Also, this is possible. We will get the same result, but it's a little bit more tidy. So you can do all the calculations first and later just state what you want to have returned, x2, x3, x4. So it's up to you, but if the calculation is long, then it's better to put it in the body, and the return statement only contains the variable name of the ones that should be returned. So let's take this back again. Also, you can have a quick test. What happens if some argument is expected, but you don't give it any? Again, function call requires brackets for sure, also without any argument. But then it won't work because this one expects an argument. So you have to send something with it, because of nothing you cannot very efficiently calculate any powers. So make sure to send something as a signature. So sometimes you don't want to send an argument every time because there is a default case that is typically used. This is the next thing that we have here. For example, you want to send in the real argument that is for that something is calculated, but typically you want a square and not any other power. So you want to write a function that calculates principally all the powers that you're interested in, i.e. taking more than one argument, the argument itself and the possible power, but standard is power of 2. You have seen this before with the logarithm. There was the standard base e, but if you wanted another, you could send another argument. This is the same that happens here with the p equals 2. You can send another power as an argument, but if you don't, then there's a standard, a default power that is used, and this is 2. By the way, I thought about the question in the break, the question with the logarithm and rounding error. So to the base of 10, it actually falls back again to the default value, but also the default value in the logarithm was e. So remember we had, let's just put it here quickly, we had log of x with no further argument calculates the natural logarithm. Just stating exactly the base would calculate something else. So the natural logarithm is the default case. I'm putting a 10 at this example. Actually, in the background falls back to the default case, but also the default case will give you rounding errors because the numbers are typically not to the base of e, as you have a computer with binary digits. So the standard base actually is on a natural base, and the computer is 2, of course, and a binary system. But nevertheless, the base that you get when you omit the second argument in logarithm is e. Anyways, it will give you rounding errors, probably only to the base of 2. You get less rounding errors. So probably that was the problem with the logarithm of 1,000 to the base of 10. It's not exactly 3 because, well, we round to binary numbers. Okay, so some little excursion to that. Then here we have the same case, the p can be omitted, then just the square is used. We have a third argument, it also has a default value, this is false. It's a debug mode, so here if debug is true, then something is printed, and if it's false, not. And returned is the pth power of x. So let's run the cell so we know my func now. And the only really required argument is the first one. One we need. If we don't say which power, we get a square, as you can see. But what we can do optionally is we can send either another power, or we say we want the debug mode, whatever that is. In this case, it just prints a statement. It's not really a debug mode. But if we set debug to true, we go in this case and then we get the result. Let's quickly check the chat for questions. There is no default value in the condition of an if, but it is set here. So here in the signature, in the function definition, we set a default value to false. So you have to set it here. That's where you set the default. There is no general default for an if condition. It's now a default because we set it up here to false. If you wouldn't have set it, we get a name error because it says debug is unknown. So now it's set to false. This is why when I run my func of 5, so I call it without debug, then we fall back to the default value. So this is false, we skip the print and directly go to return. If I set it to true, then this is evaluated. As you can see, I wrote here explicitly debug is equals to true. Now think for yourself, if I remove this, what happens now if I run this? You can think for yourself for a second. What would happen? Let's try it. So we get just a 5 because now this is something that was unexpected. Because if you do not write debug here, if you not name the argument by its name as in the function definition, then it is assumed that you keep the order that you have. So when I write this without a debug, it expects the true to be the value of the second argument because I did not name it. If you don't name it, you have to keep the order. So it assumed that true probably is supposed to be the power, and apparently it implicitly typecasted the true to a 1. You don't even get a type error. So you can apparently calculate 5 to the power of true because implicitly it dynamically typecasts it to a 1. So what was calculated here was lastly this, yeah, with the typecast of true to 1, which is very often. You can think of this as practical, but it can cause trouble. Sometimes it's practical. Sometimes it's better if you do it like in C and you have to explicitly say what you mean, what type, and there's no implicit typecasting. So, but by saying the name, I can take it to any position. Yeah? So if I say debug is supposed to be true, then I can place it in the second position, it's not a problem. Now we go into debug mode. Actually, if you give the name, you need to know it for that. So you have to know the source code. Otherwise, you don't know what are the names. But if you do, you can do any order. And for example, also put the X in the last position. So this would work and gives you the power, 7 to the power of 3 in debug mode. Okay. The last thing, I think it's last, yes, we do with functions for your next task, unnamed functions. They are fun, actually. Mathematicians like them. Also, maybe if you come from linguistics, you know lambda functions. You can also call them unnamed functions. But lambda is the keyword. That's why you cannot use it for a variable. So, unnamed function basically means that the keyword says, now this is a function and we can skip all the part with def and function name. You see, there is no function name and no def keyword. This is basically compressed into the lambda. So is a general placeholder for a function, but you have to name the argument. So F1 basically now is a function it's not a function call, it's not the evaluation of a function. It's a function that tells us the lambda keyword, and it takes an x and returns the square. So this is equivalent to the following. You can also use def and a name, but you have to come up with a name, and here you don't. Also, you have to return something. Here, this is implicitly clear that you return everything that is calculated after dump point. So either or, you can use F1, F2, they will do the same. Let's check it. Well, nothing happens. Yes, now. So if I call F1 of 2 and F2 of 2 both return 4. Of course, now using this, I also named the function. So it's not really unnamed anymore, but that's not the point. You can, of course, still give it a name. Still, you see, it's shorter, it's one line. You can compress it into one line. You don't need this indentation. So for short function, it's helpful to use lambda. But especially if you don't want to give it a name, because you only need it once and send it to some other function anyway. And a very, very typical example is the map function. There you have this. Map is a Python function. As the name already says, it's kind of a mapping. So it is also some sort of function. It evaluates a given function in a given range or for a given values. So map, you can check now for yourself. Go to your console, type help map to see what it does. Takes 2 arguments. If you don't believe, you check now for yourself with the help statement. It takes 2 arguments. It takes a function. Values that are sent into the function. So you map these values to the function values from that function. So map of this basically says I want from -3 to 4, saying from -3 to 3 included, the square. So please evaluate this squaring function in the range from -3 to 4. This is what map does. It evaluates a function. So give it a function and give it the values where you require a function value. This is one of the examples where it's maybe not so really necessary to predefine it and give the function a name. Just quickly send it into map. You only want results. You don't care of any function names. By the way, this is something specific for Python 3. Map is a specific map object unless you convert it into a list. So you have to do this list to get the real values out of it. Otherwise, I will show you, you get just a map object. So what did I do? I sent into this map a function I wanted to map, the squaring. And I sent range -3, -2, -1, etc. up to 3. Please evaluate the function at these points or at these x coordinates, and this gives me y values. All the squares. The list. Is there a question? No. The list is necessary to give you the values only in Python 3. In Python 2, you get the list directly. I show you what happens when you leave this out. Then you just get a weird map object. It says this is a map. So basically it's just an object that evaluates a function, but usually you're interested in the values. So very common error source, if this happens, typecast it into a list and then you'd get the results. So map is really useful. Keep this in mind. Now there's the next task for you. Try it yourself. it's two main tasks and one is split into two versions. So I hope you can see all this. So please implement a function with two lists of ints. Here the lists of ints, you come up with your own values. Take whatever you want, just whatever you're interested. 7, 13, 4, put what you want. So the function takes two lists of ints and should create a third list. So input arguments two lists of ints, return another list containing only odd numbers from the first list and even numbers from the second list. And if you have time, try two versions. Try one with list comprehension and a normal version. So really play around with the list comprehension, it's fun. And for task B is also two ways necessary. Please calculate the squares of a list of elements. One time you should use the map function and do an element-wise calculation. Or in the second case, you use a function call to a function that requires a list. So not element-wise, but the list goes completely into a function. So again, you have time now to work on the task. Feel free to send questions or solutions into the chat, and then we can discuss in a few minutes. Again, use the help function or Google. If you forgot what map does or so, then look it up. Again, feel free to send solutions in the chat, either to everyone or to me, or also post questions. Also, if I have a solution, you can send so I know if you are already done or if you maybe need more time. So maybe you can work a few more minutes, maximum 5 minutes on the task, and then we will have a look at possible solutions. Oh, 5 minutes, please. In the chat, so feel free to proceed. It's important that you try on your own. That's way more important than listening what I said to you. So take your time. So there is a solution. Feel free to send what you got. Also, if you have something that doesn't work, then maybe we can figure out what's going on. That's pretty much what I will present to you in a second, so very good. It's also probably the straightforward way. Just do the first list, do the second. You don't have to do them at the same time. Also the list comprehension, nice idea. Also here, straightforward to do just two lists separately with list comprehension and then concatenate them. So then I would suggest that we have a look at the solution. Feel free to play around more, even if you know a few solutions already, there's always a possibility to come up with another version. So let's check. Again, the task was, we have, again? No question? We have two lists of ints. Just define them on your own, and we want a third list taking the odd numbers of the first and the even numbers of the second list. Put them together, return the new list. Two versions, one using list comprehension, so let's check. So here are two lists containing integers. You can use any, just for testing reasons, make sure that both of them contain a few odd and a few even numbers. Otherwise, it's not a very good test case, of course. So the function definition is here of the first version. So the function's name is merge list. Apparently it's not only merge, but kicking out unwanted values. It has two arguments, and they are both necessary because you can only merge two lists if you have two lists. And then you define again, as you have seen before, an empty list. Remember, there was also the option to write list with the round brackets, or just put list brackets and nothing in between. And then you just do this one after the other. There's no need to do it at the same time. So you iterate over list one, name the elements as you like for all the elements in list one. Now, condition, if this is in that case in list one an odd number, then we want to append it. This is the condition for appending. Only odd numbers of the first list, or in other words, you just check if modulo 2 it's not 0, i.e. it's 1. So if so, it's odd, so you append it. Then you take the second list, just the condition is different, you iterate over the elements, and now you check if the number is even, and if so, you append it. So this should, we can think for ourselves what would happen. This should get, oh, my screen went dark. I don't know if you can still hear me, but I cannot see anything. I don't know why.
Me gusta tal cosa. Qué puta, ya. Pero qué cosa
Hola, buenas tardes. ¿Me pueden escuchar? Vanessa me
Sí,
iba a
y Stefan, Stefan
Sí,
te
Vanessa
escuchamos.
me ha escrito que parece que hay problemas técnicos. Probablemente es con su internet un problema. Eso también pasa en Alemania. Entonces creo que como estamos casi al final de la sesión, sugiero que continuamos en una semana. O sea,
Ok,
el
sí.
mismo sábado a la misma hora creo que es.
Sí, el
De la
sábado de
tarde.
1 a 5, sí.
Sí.
Gracias, Stefan. Entonces, terminamos allí por hoy día. Si problemas de internet ocurre en cualquier lugar del mundo, ¿no? Ok, Stefan, muchas gracias. Entonces, también ahí hay una tarea pendiente que dejó Vanessa. Y continuamos la próxima semana de 1 a 5. Esperamos que, bueno, no haya inconvenientes, ojalá, ¿no? Sí, gracias, Stefan, por avisarnos. ¿No?
Ok, muchas gracias y mil disculpas y bueno,
No,
esperamos
no,
que la
pues
próxima
estamos,
semana será mejor.
sí, sí, esperemos Dios quiera que todo salga bien, pero muy interesante el curso, muy, no. Y gracias también, Stefan, saludos desde Perú. Ok, saludos a Vanessa también, gracias. Nos despedimos
Gracias.
entonces hasta la próxima semana. Estimados participantes, tengan a bien llenar su formato de asistencia. Ahí está, ¿ya? Y quedamos despedidos hasta la próxima semana con el mini curso de Python de 1 a 5. ¿Ok? Gracias por su asistencia.
Invitamos a la plenaria a las 5 de la tarde, por favor. Regresan si salen un rato.
No entiendo.
Estamos recordando los asistentes con las 5 de la tarde de la plenaria el día de hoy. En la sala para que puedan escuchar la plenaria. También su asistencia. Muy bien, hacemos recordar a todos los asistentes que a las 5 en punto de la tarde se va a estar dando la plenaria programada para el día de hoy. Así que pueden aprovechar este momento para rellenar el link de asistencia que se encuentra en el chat, así como también tomar un pequeño refrigerio y esperar para el desarrollo de la plenaria que se hará dentro de 20 minutos exactamente, el inicio de la plenaria programada para el día de hoy. En este 10º Congreso Internacional de Matemática Aplicada y Computacional. Nos vemos a las 5 en punto, los esperamos.